Hi, I wanted to go over with you a little bit about lines and angles um, and shapes. These are things that are related to one another, as we will see. Okay, so the first thing, let's talk about lines first of all. A line, for example, a straight line. Um, okay, that is going infinitely into directions. We usually represent with two arrows at each end, and that is just what we call a line. A line is these points, that are going straight in one dimension, and they are infinitely going in both directions. Okay. A line segment is simply one region inside of an infinite line. All right. So this would be your segment, your line segment. And if you were to just take a line and go only in one direction, then we would call it a ray. So if we are starting from one end and only going in one direction, then we call this a ray. Okay, and there's a few ways to draw a ray or a line that only goes in one, that only extends in one direction. Okay, now if you have two lines, okay, I'm just going to draw two lines. I'm going to draw them this way. Two lines, they may or may not intersect, because we've got two lines, they may or may not intersect depending on if they're angling towards one another. Okay, so what does that mean? Well, if they never intersect, okay, and I've only implied it the way I've drawn here, but the definition of lines that never intersect is known as parallel. Okay, and these never cross, they never intersect. Okay, but lines may intersect. Okay, if they're not parallel, it means that they may intersect. So here's a couple of lines, and I'm drawing like sort of infinite lines with the arrows, right? And so these lines do cross. So these lines are not parallel, and they intersect at a point. Okay? Now, when two lines intersect at a point, they form angles, or the distance, that tells you how far apart radially, okay, one line is from another, right? And we've got an instrument that measures this. So this would be the angle. The angle is simply the distance of the lines as they open from a particular point known as a vertex. All right, this is known as the angle. Okay, and the point where they unite, the point of intersection, can be called the vertex. Okay, so now if I just draw two rays, okay, I'm going to redraw what I drew here. If I just draw two rays, so here's one ray, here's another ray, okay, I can actually label points in the ray. So I'm going to pretend that this ray actually has a finite point. So instead of two rays, maybe two line segments. I'm going to label this point up here on the top ray A. I'm going to label the vertex B, and I'm going to label another point on the bottom ray C. Okay, so you've got a line or a ray BA, which we symbolize like that, and we got another one here BC, which we symbolize like this. Okay, so there exists an angle, okay, that represents roughly the distance, or really the grade of opening between ray BA and ray BC. Okay, and you can measure this with your device, which we call a protractor. Okay, so you've got this little device that you allow to be crossed by both lines BA and BC, and in this device there are markings, and those markings tell you the degrees or the sort of radial distance between these two lines. Okay, you can measure that. All right, and so this is what we call an angle. Now, lines can make shapes. Okay, so lines can make shapes. Okay, so we can make, for example, a square. Okay, and lines in a square are joined at these vertices. Okay, and you have a shape. the side of that shape, okay, which is formed by a line, was no longer called a line. Now we call this an edge. Okay, the vertex is still the vertex because that is the joining of two lines. Okay, but the line that represents the side of the shape is no longer called a line. Now we call it an edge. Okay, now because these are lines that are also intersecting at that vertex, so there's a vertex here and there's many vertices, which is just a plural. Then, because it's two lines always form angles, okay? Now, I'm drawing the angle as a little sort of bracket here, like a little square bracket here, because the angle in a square is actually perfectly 90 degrees, okay? So squares have vertices that are 90-degree angles, which are also known as right angles. Okay, and if you know the nature of the edges of a shape and the measure of the angles of a shape, then you'll know a lot of information about that shape. For example, so drawing the square, right? So I can actually draw a perfect square here, right? So that's a square. So we know something about the square. First of all, we know that the edges, okay, are same distance, okay, or length. Okay, that's part of the definition of a square. Okay, so squares have all these vertices here. There's a vertex right there. There's a vertex, and every single vertex of a square is a right angle, okay, 90 degrees, which is also known as a right angle. But if they're not right angles, okay, we can draw another shape that looks like a square, but it's not, and it's called a rhombus. Okay, now the rhombus also has lines, edges. Okay, so this edge and all four edges, really, all edges are the same length. Okay, but the angles that are formed by the lines, by the edges that form the shape, all right, this angle are here, this angle are here, this angle and this angle, these are not right angles. In fact, two of these angles I'm going to call the edge A and B, the angles formed by the edges A and B, are bigger than 90 degrees, so we call them obtuse. And the angles formed by, that are in points C and D, the vertices C and D, these angles C and D are what we call acute angles, or angles that are less than 90 degrees. All right. So another thing that another similarity between rhombuses and squares, so the last thing I'm going to leave you with, okay, is that these sides in a square, these two edges, are parallel to one another. Okay? And in the rhombus, these two edges are parallel to one another. Okay? So in both a square and in a rhombus, opposite edges, okay, opposite edges in a square and in a rhombus are parallel to one another. Okay? So even though there are many similarities between squares, we have opposite edges are parallel, and we've got opposite angles are identical in both the square and the rhombus, except that the rhombus has two of these angles be obtuse and two of them be acute. All right, and the edges of both the square and the rhombus are equal in length. Okay, so we have a lot of information about the shape that is actually given by both the line and the angle nature that forms these shapes. All right. So look through this a couple of times. We'll talk about other shapes later on, okay? And feel free to pause it. And if you've got any questions, let me know.